Hi there, this is Tang from the Deep Real Lab. Thank you for taking the time to explore our work inside the visual mind, neuroscience-motivated concept circuits for interpreting and steering vision transformers. This work is a collaborative effort with Yanlin, Meng, and my advisor, Professor Peng. Most interpretation methods tell us what input features influence predictions, but they rarely explain how the machine learning models internally reason. In this work, we ask if we can move from correlations to the cognition, or in other words, can we read the mind of AI? Cognitive science offers two views of the brain. One study connections between neurons, and the other study representations and their transformations. Similarly, AI interpretation has bottom-up circuit analysis and top-down representation analysis. However, both have limitations. The bottom-up view lacks the local semantics of the model components, while the top-down view lacks the global structure of the model. A question naturally arises: can we bridge the bottom-up and top-down interpretations to develop the real cognitive science of AI? To fill the gaps, we propose ViSAE, a toolbox with three parts: a neuroscience-motivated probing suite, a concept circuit tracing algorithm, and applications for auditing and steering ViTs. Our probing suite is inspired by the human visual systems. It covers four major levels of visual abstractions. This gives us 64,000 images with much broader concept coverage than the ImageNet. We then use large language models to summarize visual concepts from these images, producing a 16,000 concept vocabulary, and human evaluations confirms the quality of these concepts. The second part is a concept circuit tracing algorithm. We first train sparse autoencoders, or SAEs, to read concepts from each ViT layer. Then we trace how concepts causally influence other concepts across layers, forming concept-level circuits inside the model. To read the concepts, we train SAEs to reconstruct the representations of each ViT layers. Then we map SAE learned features to language concepts using cliffs shared embedding space. Given the SAE and the concept dictionary, now we can read the concept directly from the representations. To trace the concept circuits, given two layers, we use the SAE encoder to identify the active concepts in both layers before any intervention. Next, we intervene on one concept by setting its activations to 0. For example, we can remove the concept sign from layer L. This is the patched version of the representation. After passing the modified representation to the next layer, we measure which concept changes. These changes reveal the causal age between the concepts. And here are some example concept circuits. For images containing both a dog and a cat, the model follows different internal concept pathways for different predictions. And our method can also localize concepts in the image. It works not only for objects, but also for abstract concepts like looking at or jumping. We can also use these concepts to diagnose model failures by comparing the concepts in the right and wrongly classified images, and summarize them into different failure modes. Beyond auditing, our toolbox allows us to steer model behavior. On the WaterBirds, we can edit the concepts related to the spurious background cues. And quantitatively, our method shows stronger steering power than existing intervention methods. Please refer to our paper for more details and experimental results. Thank you all for listening.